Welcome to the Architect of a Dream channel. Today we will journey to the quietest and most unsettling corners of the universe, to places where reality is more frightening than any fiction. We won't be talking about imaginary monsters or ghosts. Our path leads to real phenomena, to silent voids the size of galaxies, to vampire stars and planets where it rains glass. These are not stories meant to scare, but to show the true scale and strangeness of the world we live in. This is a quiet horror, born of knowledge, of realizing our tiny place in this incomprehensible theater of shadows and light. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and your mind soften. Let us begin. Imagine a room in our cosmic home so vast and empty that its existence seems like a mistake of creation. This is not just a metaphor, but a physical reality named the Boots Void, the great nothing in the structure of the universe. It is a colossal, almost perfectly spherical region of space, about 330 million light-years in diameter, where there is almost none of what we are used to calling matter. If our Milky Way galaxy were at its center, we would look up at the night sky and see only our closest neighbors, and beyond them, absolute impenetrable blackness. We would not have known about the existence of other galaxies until the 1960s, when technology would have allowed us to peer over the edge of this abyss. This cosmic desert is so large that its existence barely fits within modern models of the universe's evolution, which predict a more uniform distribution of matter across the cosmic web. This is not just an absence of light, it is a tangible, oppressive presence of nothing, a reminder that the universe, at its core, is silence and emptiness, and galaxies are but rare, glowing specks of dust in this infinite ocean of darkness. And in the very heart of this void, as in all of intergalactic space, a cold unlike anything on Earth reigns. Absolute zero, the theoretical limit of cold, is minus 273, 15 degrees Celsius, but even this great void does not reach it. It is faintly warm, heated by the last breath of creation. It is warmed by the cosmic microwave background radiation, the quiet afterglow of the Big Bang, left over from an era when the entire universe was a fireball. Now its temperature is only 2.7 Kelvin, or minus 270 degrees Celsius. This cold does not burn like an earthly frost. It simply stops motion itself. It steals energy. Any unprotected object finding itself here would slowly and inexorably radiate its heat into the void until its atoms slow their dance to an almost complete stop. It would turn into a silent, icy monument to itself, frozen in eternity. This is the cold of oblivion, a cold that erases energy and history, equating everything with the background whisper of the cosmos, with its primordial lullaby. But even in this icy silence, there are ghosts of its own, echoes of long-past events imprinted on the map of ancient light. The cosmic microwave background, this quiet backdrop of cosmic microwave noise, carries the imprint of an anomaly known as the CMB cold spot. It is a vast region of the sky that is inexplicably colder than its surroundings by a fraction of a degree, as if someone had placed an icy finger on the infant face of the universe. One hypothesis, resembling an ancient myth, suggests that it is a trace, a cosmic bruise from the collision of our universe with another parallel universe in the distant, hazy past. We cannot prove this, but the very possibility makes the heart stop. We can literally see on the most ancient map of light the scar from the touch of another world, a ghostly mark on the fabric of our existence. It is a reminder that our world may not be alone, but its neighbors might only leave cold scars on the body of reality. This fabric of existence, space-time itself, is not an immutable and eternal stage for cosmic dramas. It can be torn to shreds by a burst of unimaginable fury. Gamma-ray bursts are the most powerful and violent releases of energy known to science, dazzling flashes that in a few seconds release more energy than our sun will in its entire 10 billion-year lifetime. They are like shots from the cannons of gods, aimed at random points in space. If such a burst were to occur in our galaxy and its narrow, focused beam were directed at Earth, it could instantly destroy the ozone layer, causing a mass extinction and sterilizing the planet's surface with streams of hard radiation. We see these flashes in distant galaxies almost every day, like the muzzle flashes of a distant, invisible war. We just hope that none of these deadly barrels ever turns in our direction, into our quiet corner of the cosmos. The source of some of these violent bursts are objects born in the death throes of giant stars, neutron stars. Imagine the entire mass of our sun, or even two suns, compressed by gravity into a sphere just 20 kilometers in diameter, a ball the size of a small city. The density of such an object is so colossal that a teaspoon of its substance would weigh billions of tons on Earth, like Mount Everest. This is no longer quite matter in our usual sense. It is one giant atomic nucleus, composed of densely packed neutrons, so-called neutronium. Protons and electrons have merged under monstrous pressure, disappearing as separate particles. Their gravity and magnetic fields reach unimaginable magnitudes, distorting the space around them beyond recognition. These are the dead, yet incredibly powerful hearts of giant stars, continuing their frantic rotation in the cosmic darkness, like spinning tops set in motion by the hand of a dying giant. And sometimes these dead hearts turn out to be even more monstrous than one can imagine. Magnetars are a special, extremely rare type of neutron star, possessing the most powerful magnetic fields in the entire known universe. Their field is a quadrillion times stronger than Earth's magnetic field, so powerful that it can distort the shape of atoms themselves, stretching them into thin needles. At a distance of 1,000 kilometers from a magnetar, its field would be instantly fatal to a human, as it would tear apart the chemical bonds in the molecules of our cells, turning the body into a cloud of plasma. Even flares on their surface, so-called starquakes, when the solid crust of the star cracks under tension, release colossal energy capable of affecting Earth's ionosphere, even from the other side of the galaxy. These are the true magnetic monsters of space, whose presence is felt across thousands of light years. These objects are so dense that they distort not only matter, but the very nature of time, causing it to flow more slowly. According to Einstein's general theory of relativity, the stronger the gravitational field, the slower time flows for an observer within that field. On the surface of a neutron star, time slows down by about 30% compared to Earth. This is not just a theory. It is a physical fact confirmed by observations. If you could spend 10 years there and return, 13 years would have already passed on Earth. This means that the universe is full of places where the very flow of time obeys different, alien rules, where moments stretch into eternity under the weight of unimaginable mass. The very concept of simultaneity loses all meaning when we speak of different gravitational potentials. Time is not a universal river, but a myriad of streams flowing at different speeds, and we live by one of the slowest and calmest. But there are objects in the universe next to which even a neutron star seems like a harmless children's toy. We are talking about black holes, about points of no return, about bottomless gravitational wells where the laws of physics fall silent. The event horizon of a black hole is not a physical surface one could step on, but an invisible boundary beyond which the velocity required to overcome gravity exceeds the speed of light. It is a threshold that, once crossed, nothing, not matter, not light, not information itself, can ever return. It is a one-way door in the universe, a one-way ticket. Everything we know about physics, all our laws and constants, cease to work beyond this invisible line, giving way to a singularity, a hypothetical point of infinite density and zero volume, where the very concept of space and time disappears into a roaring infinity. The process of falling into a sufficiently large black hole has been given a poetic and simultaneously terrifying name: spaghettification. Because a black hole's gravity weakens with distance, the gravitational force acting on your feet would be immeasurably greater than the force acting on your head as you fall feet first. As a result, your body would be stretched more and more, like spaghetti, turning into a thin, elongated stream of atoms rushing toward the singularity. This is not a quick and merciful death, but a methodical, inexorable stretching and tearing of the very fabric of your being at a subatomic level. It is an absolute deconstruction, a return to the primordial chaos from which the universe was once born. It is not just the death of the body, but the erasure of form and structure itself, a transformation into a faceless stream of energy and matter disappearing beyond the horizon. Not only are there black holes born from the collapse of individual stars, but also true monsters lurking in the hearts of almost all large galaxies. Supermassive black holes can have masses millions or even billions of times greater than that of our Sun. Our own galaxy, the Milky Way, revolves in a gigantic dance around such a monster, known as Sagittarius A. We and hundreds of billions of other stars circle in this cosmic dance around a point of no return, around a maw that slowly devours stars and gas clouds that dare to approach too closely. Our entire galactic family, our entire stellar home, exists at the mercy of this invisible gravitational overlord whose presence orders the chaos, but whose proximity means inevitable doom. He is the dark shepherd, gathering his flock in an eternal dance around the abyss. Sometimes these galactic monsters do not sit still in their centers, but embark on a journey, becoming invisible predators. There are compelling hypotheses about the existence of rogue black holes, objects that have been ejected from the centers of their galaxies as a result of complex gravitational interactions, for example, during the merger of two galaxies. Now they hurtle through intergalactic space at speeds of hundreds of kilometers per second. They are completely invisible. They can only be detected by their gravitational influence on the light of distant stars, or by the chaos they sow as they pass through star systems. Imagine an invisible predator with the mass of millions of suns that could cross our galaxy's path at any moment. We would never see its approach. We would only feel its destructive gravitational tread as it begins to tear our stellar home apart. Even light, the fastest thing in the universe, cannot escape their gravitational embrace, but it can tell us of their presence, becoming their unwitting messenger. Gravitational lensing is an amazing effect in which a massive object, such as a black hole or an entire galaxy cluster, distorts space-time with its field, causing light from more distant objects to bend as if passing through a giant invisible lens. Sometimes this creates bizarre, multiple images of the same distant galaxy, so-called Einstein crosses or perfect Einstein rings. We see ghostly, distorted reflections of distant quasars and galaxies, their light having traveled for billions of years and bent by the invisible presence of a colossal mass. It is as if the universe itself were giving us a chance to look around a corner, using gravity as a distorted mirror showing ghosts of the past. But what happens to the very essence of things, to the information that falls into a black hole and disappears forever? According to the laws of quantum mechanics, information cannot be destroyed without a trace. According to the general theory of relativity, nothing can escape a black hole. This fundamental conflict between the two pillars of modern physics is known as the black hole information paradox. Where does the information about the particles that have crossed the event horizon disappear to? Stephen Hawking proposed that black holes slowly evaporate by emitting radiation. But is this radiation random thermal noise, or does it carry subtly encoded information about all the absorbed matter? This question remains one of the greatest mysteries facing physicists, and its solution may require a new, deeper theory of reality that unifies gravity and the quantum world. Besides these gravitational monsters, space is full of stars whose behavior resembles a grim horror movie script about eternal youth at someone else's expense. In ancient globular clusters where all stars should be old and red, astronomers find so-called blue stragglers, or vampire stars. These are stars that appear anomalously young, hot, and blue compared to their peers. It is believed that they extend their life and youth by literally siphoning hydrogen fuel from a neighboring companion star through a gravitational bridge. They remain bright and full of vigor while their victim slowly fades, turning into a dim white dwarf or disappearing altogether. This is a quiet, ruthless cosmic cannibalism stretched out over millions of years, an eternal drama playing out in densely populated stellar cities. And then there are what could be called zombie stars, rising from the dead for one last, furious act. When a white dwarf, the cold and dense dead remnant of a small star like our Sun, is in a binary system, it can begin to pull matter onto itself from its living companion. Having accumulated enough mass and exceeded the critical Chandrasekhar limit, it becomes unstable, and a thermonuclear reaction ignites in its core. The dead star explodes as a supernova, a so-called Type Ia supernova. This is a dead man rising from the grave to produce one of the brightest and most predictable explosions in the universe before finally disappearing into oblivion. It is a short, furious, and posthumous rampage, a dazzling echo of a former life that, for a moment, outshines an entire galaxy. Speed in space can also be a source of quiet horror when it means eternal exile from home. Hypervelocity stars are stars moving so fast that they are able to overcome the gravitational pull of our galaxy and fly off into infinite intergalactic space. Their speed can reach millions of kilometers per hour, which is tens of times greater than the speed of ordinary stars. It is believed that they receive such a monstrous acceleration by passing too close to the supermassive black hole at the center of the galaxy, which acts like a giant gravitational slingshot. These stars are eternal exiles, doomed to a lonely journey into the great void between galaxies, one day to become the only star in the sky for a hypothetical observer in the distant future, a lone flicker of light in absolute darkness. But it is not only stars that can be exiled from their homes and doomed to eternal wandering. Entire worlds can also become eternal orphans. There are also orphan planets, or rogue planets, which do not orbit any star. They were ejected from their native star systems at the dawn of their formation as a result of gravitational chaos, like billiard balls in a cosmic game. Now they drift in complete darkness and icy cold through the abyss of interstellar space. It is estimated that there may be billions or even trillions of them in our galaxy alone, more than there are stars. These are dark, frozen worlds, devoid of the light and heat of a star, eternal wanderers in the cosmic night. Perhaps, on some of them, life still glimmers beneath a thick ice crust, sustained by geothermal heat from the planet's core, a life that has never known a sun. Sometimes, uninvited guests from these dark, cold expanses visit our solar system, bringing with them the mysteries of the interstellar abyss. In 2017, astronomers discovered the first known interstellar object to pass through our home, an asteroid or comet given the Hawaiian name Oumuamua, which means scout or messenger from afar. Its strange, elongated cigar-like shape, its dim reddish color, and its unusual trajectory, which showed acceleration not explainable by gravity alone, generated a mass of debate and hypotheses, even to the point of suggesting an artificial origin. It was unlike anything we had seen before in our system. It was the first silent and mysterious wanderer that sped past us and disappeared again into the abyss, leaving behind more questions than answers and reminding us that space is full of surprises. Our own solar system, which seems so familiar and cozy, is also full of places that can hardly be called hospitable. Take, for example, Venus, our twin sister in size and mass, which followed a completely different, hellish path of development. Its atmosphere is 96% carbon dioxide, and the surface pressure is 92 times higher than Earth's, the same as at a depth of a kilometer underwater in Earth's ocean. The temperature there reaches 460 degrees Celsius, which is hot enough to melt lead and zinc. And to top it all off, it rains concentrated sulfuric acid from the sky, which, however, evaporates before reaching the scorching surface. This is not just a hellish landscape from ancient legends. It is a real world and a possible future for Earth if a runaway greenhouse effect gets out of control. Or let's look at Jupiter, the gas giant, our older brother, who with his powerful gravitational field protects us from many comets and asteroids. Its famous Great Red Spot is a gigantic hurricane anticyclone that has been raging for hundreds of years and into which 2 or 3 Earths could easily fit. Winds in its multicolored atmosphere reach speeds of over 600 kilometers per hour. And deep inside, under layers of clouds of ammonia and water, the pressure is so great that hydrogen, the planet's main component, transitions into an exotic metallic state, creating the most powerful magnetic field among all the planets in the solar system. This is a world of eternal storms and unimaginable pressure, where there is no solid surface to stand on, only an endless fall into the depths. Jupiter's moons are no less harsh and amazing, each of them a world of extremes. Io, the closest of the 4 Galilean moons, is the most volcanically active body in the entire solar system. Its yellow-orange surface is constantly being reshaped by hundreds of active volcanoes, which erupt sulfur and sulfur dioxide up to 500 kilometers into space, creating a plasma torus around the planet. This unceasing geological activity is the result of a gravitational tug-of-war between massive Jupiter on one side and the other large moons, Europa and Ganymede, on the other. These tidal forces literally knead and heat Io's interior, like a piece of clay in a potter's hands. It is a world that continuously turns itself inside out in eternal agony. Another famous moon of Jupiter, Europa, hides a global ocean of liquid water, possibly salty, beneath its smooth, cracked, icy crust. It is estimated that this subsurface ocean may contain twice or even 3 times more water than all of Earth's oceans and seas combined. This makes Europa one of the most promising places to search for extraterrestrial life. But this icy crust is tens of kilometers thick. Any hypothetical life there exists in eternal, impenetrable darkness and icy cold, under colossal pressure, in a world that has never seen the light of its star. It is life locked in an icy prison, possibly existing thanks to the heat from hydrothermal vents on the floor of this bottomless ocean, like on the floors of our own terrestrial seas. Let's move on to Saturn, the ringed giant, the pearl of the solar system, and its largest moon. Titan is the only moon in our system with a dense, hazy atmosphere, even denser than Earth's. But this atmosphere consists mainly of nitrogen and methane rain falls from the sky, filling lakes and rivers. On Titan's surface, rivers flow. There are lakes and entire seas, but they are composed not of water, but of liquid methane and ethane. The temperature there is around minus 180 degrees Celsius. It is a distorted cryogenic reflection of early Earth, a world where water is as hard as rock, and mountains and cliffs are made of water ice. It is an alien, yet eerily familiar landscape, where substances familiar to us play completely different roles, creating a world in reverse. And on the gas giants themselves, Jupiter and Saturn, the conditions in the depths of their atmospheres are such that carbon, one of the basic elements of life, can be compressed into diamonds. Scientists theorize that in the upper layers of the atmosphere, powerful lightning, thousands of times stronger than on Earth, turns methane into carbon soot. These soot particles then, falling deeper into the planet, under the influence of colossal, increasing pressure and temperature, turn first into graphite and then into real, solid diamonds. These diamond hailstones, which can reach a centimeter or more in size, continue their fall until they reach layers so hot that they melt in the incandescent depths of the planet. There, in eternal darkness, it rains the most expensive gemstones on Earth, forming entire seas of liquid diamond. Even on the icy edge of our system, on the distant giants Uranus and Neptune, strange and harsh weather reigns. Unlike that on Earth, the wind speeds on Neptune are the highest in the solar system, exceeding 2,000 kilometers per hour, which is several times faster than the speed of sound. These are supersonic flows of frozen methane ice, rushing in the planet's eternal blue haze, where dark, Earth-sized vortices rage. And Uranus rotates, lying on its side. Its axis of rotation is tilted by almost 98 degrees to the plane of its orbit. This leads to the most extreme seasons in the solar system, where each hemisphere is plunged for 42 Earth years into either continuous sunlight or complete freezing darkness. It is a world of overturned horizons and endless days and nights, a world that lives by its own strange rules. Now let's look beyond our system at the infinite variety of exoplanets, worlds around other stars, where nature surpasses the wildest fantasies. There is a planet, HD 189733b, a hot Jupiter, which from a distance appears as a beautiful, deep blue sphere, reminiscent of Earth. But this color is not from oceans. It is imparted to the atmosphere by microscopic particles of silicates, that is, molten sand. And the winds on this planet blow at a speed of 8,700 kilometers per hour, which is 7 times faster than the speed of sound. This means that on this planet, there are horizontal rains of molten glass, flying at an unimaginable speed. It is a world of unimaginable beauty and equally unimaginable, instant and brutal death for anything that might find its way there. There is also a planet that challenges our very understanding of how and when planets can form, a true cosmic elder. This is PSR B162026b, nicknamed Methuselah for its incredible age. Its age is estimated at 12.7 billion years. It is almost as old as the universe itself. It formed when the universe was still very young, and there were almost no heavy elements in it, such as carbon and oxygen, which are considered necessary for the creation of planets. This ancient elder world orbits an exotic pair of 2 dead stars, a pulsar and a white dwarf, in the very heart of an old globular cluster. It has seen the birth and death of its suns and continues its endless journey in eternity, like a living fossil from the era of creation. There are also planets that are one continuous water surface, so-called ocean planets, worlds without a single patch of land. For example, the planet Kepler 22b, which is in its star's habitable zone, which theoretically allows water to be liquid. But if there is any land on it, it is hidden under a global ocean hundreds and perhaps thousands of kilometers deep. Under this bottomless expanse of water, under colossal pressure of millions of atmospheres, ordinary water transitions into exotic high-pressure states, such as hot ice or ice 7, which remains solid even at high temperatures. These are worlds without shores, without a solid surface. Underfoot, only an endless expanse of water over an even stranger form of the same water, where the ocean floor is ice. And there is the opposite, fiery extreme, the planet Coro T7b, which orbits so close to its star that a year on it lasts only 20 Earth hours. One of its sides is constantly facing the star, and the temperature there reaches 2200 degrees Celsius, which is higher than the melting point of many metals and rocks. The other side, conversely, is plunged into eternal night and relative cold. It is theorized that on this planet, rocks evaporate on the day side, form rock clouds, which winds carry to the night side, where they condense and fall as rock rain or even rock snow. This is a world where geology and meteorology have merged into a single, furious cycle of rock. Evaporation and condensation, a world of a perpetual rock cycle. Even our own Earth, which seems like such a safe haven, is not completely protected from invisible cosmic threats. Our planet is constantly bombarded by cosmic rays, high-energy particles, protons, and atomic nuclei coming from the sun and from the depths of space after supernova explosions. Most of them are deflected by the magnetosphere and absorbed by the atmosphere. But some of them, especially secondary particles like muons, reach the surface and pass through everything in their path, including our bodies. Every second, hundreds of these invisible particles fly through the palm of your hand. We live under a constant, invisible rain of debris from distant cosmic cataclysms without even suspecting it, bathing in the ghostly echo of stellar deaths. Our main defense against this rain, the Earth's magnetosphere, is not eternal or constant. It lives its own slow life. It is generated by the movement of liquid iron in our planet's outer core, acting like a giant dynamo. And from time to time, on average every few 100,000 years, this system falters and the field weakens and flips. The north and south magnetic poles switch places. During such a reversal, which can last for thousands of years, the magnetic field weakens significantly, making the planet's surface much more vulnerable to the destructive solar wind and cosmic rays. We do not know exactly when the next reversal will occur, but geological data suggests that we are already significantly overdue on the average schedule, and the shield that protects us may weaken. The sun, our source of life, light, and heat, is also a source of a constant and serious threat capable of throwing our civilization back in time. Solar flares and coronal mass ejections can send giant clouds of plasma and streams of charged particles toward Earth. A powerful flare directed straight at us could cause an extreme geomagnetic storm, capable of disabling orbital satellites, disrupting all forms of communication, and even destroying electrical grids across entire continents, causing cascading blackouts. The Carrington event in 1859 was just that. And in our technologically dependent era, its recurrence would lead to the collapse of modern civilization. We live at the mercy of our star's fickle mood. And one day, undoubtedly, our sun will die, and with it, our world will die too, incinerated in the embrace of its creator. In about 5 billion years, it will exhaust the hydrogen fuel in its core and begin to burn it in a shell, expanding and turning into a red giant. Its swollen outer layers will engulf Mercury and Venus, and its surface will approach Earth's orbit. Our planet will either be incinerated and absorbed by the expanding star, or, if it survives on a more distant orbit, it will turn into a scorched, lifeless ball of molten rock. The end of our world is predetermined, written in the laws of stellar evolution, in the life cycle of our home star. Our cradle is not eternal, and one day it will become our grave. But threats can also come from the outside, from our own solar system, from the cosmic shooting gallery in which we live. The asteroid belt between Mars and Jupiter is the remnant of a protoplanetary disk that never managed to form a full-fledged planet due to Jupiter's powerful gravitational influence. It contains millions of rocky and metallic chunks, from dust specks to objects the size of a small country, and the trajectories of some of them cross Earth's orbit. The impact of a sufficiently large asteroid, similar to the one that ended the age of dinosaurs 66 million years ago, is not a matter of if, but when on a geological timescale. We live in a cosmic shooting gallery, and sometimes we are the target. Far beyond the orbit of Neptune, at the outermost frontiers of our system, lies the Oort cloud, a hypothetical but widely accepted spherical region consisting of trillions of icy bodies, cometary nuclei. It is the most distant and largest reservoir of objects in the solar system, extending almost a light year from the Sun. Sometimes, a gravitational disturbance from a passing star or a galactic tide can knock one of these icy chunks from its stable orbit and send it on a long journey toward the inner planets. Such comet showers, caused by external disturbances, may have been the cause of some mass extinctions in the past. Our home is surrounded by a dormant army of icy projectiles, biding their time. The universe is not static. It is expanding, and this expansion, as we learned at the end of the 20th century, is accelerating, carrying galaxies away from each other ever faster. This means that distant galaxies are receding from us faster and faster. There will come a moment in the distant future when the light from the most distant of them will simply be unable to reach us. They will disappear beyond the cosmic horizon, like ships sailing over the edge of the world. The night sky for our distant descendants, if they exist, will be practically empty and black. They will see only the stars of our local group of galaxies, while the rest of the universe will be hidden from view forever, leaving them with a sense of complete and absolute cosmic loneliness in an island universe amidst an infinite darkness. This mysterious accelerated expansion is attributed to an even more mysterious force or substance called dark energy. It makes up about 68% of all the mass energy in the universe, but we have no idea what it is. It acts as a kind of anti-gravity, permeating space itself and causing it to push itself apart. One of the most terrifying theories about its future, the Big Rip, suggests that if the density of dark energy increases over time, it will eventually tear apart all bound structures. First, superclusters of galaxies, then the galaxies themselves, then star systems, planets, and in the very last fractions of a second, molecules, atoms, and elementary particles. It will be the end of everything, the disintegration of the very fabric of being at the atomic level. Another great mystery of modern cosmology is dark matter, the invisible skeleton of the universe. About 27% of the universe is composed of this invisible substance, which does not emit, absorb, or reflect light. We know it exists because we see its undeniable gravitational influence. It keeps galaxies from flying apart, causing them to rotate faster than their visible mass would allow, and it bends the light from distant objects. But it does not interact with ordinary matter in any other way known to us. Right now, streams of these invisible particles, which make up most of the mass of the universe, are passing through your body, through our entire planet. We live in a world that is, for the most part, completely invisible and intangible to us, like ghosts in our own home. Our entire Milky Way galaxy, along with the neighboring Andromeda and dozens of smaller galaxies, is hurtling through space at a speed of over 2 million kilometers per hour. But where to? We are moving in the direction of a mysterious gravitational anomaly known as the Great Attractor. It is not a single object, but apparently the center of mass of the enormous Laniakea supercluster, part of which is hidden from us behind a dense veil of dust and stars of the Milky Way. We and hundreds of thousands of other galaxies are being inexorably pulled toward this invisible point in space, like a gigantic river flowing into an unseen gravitational ocean. We are but grains of sand in this colossal stream, heading toward an unknown destiny, obeying a pull whose source we cannot even properly discern. There is an even more frightening and abstract cosmological hypothesis, the theory of false vacuum decay, which speaks to the fragility of our very reality. It suggests that the vacuum of our universe, empty space itself, is not actually in its lowest and most stable energy state. It resides in a false, metastable state, like a ball resting not at the bottom of a valley, but in a small dip on the side of a hill. If anywhere in the universe at any moment, even a tiny patch of space were to spontaneously fall into the true, lower energy state, it would trigger the formation of a bubble of true vacuum that would expand at the speed of light, destroying everything in its path and altering the fundamental laws of physics. We would never see it coming. Reality would simply be replaced by another, alien to us and possibly lifeless. And what if our universe is not the only one, but just one of an infinite number, a single grain of sand on an endless beach? The theory of eternal inflation and string theory suggests the existence of a multiverse, an ensemble or foam of an infinite number of parallel universes, each with its own laws of physics and set of fundamental constants. Perhaps other universes have a different number of spatial dimensions, a different strength of gravity, a different speed of light. We are trapped in our bubble, unable to know what lies beyond it, knowing only that our existence, our laws, our very reality is just one of an infinite number of random outcomes in this cosmic lottery. Our universe may not be the rule, but the exception. In this infinite multiverse, according to some interpretations of quantum mechanics, everything that can happen with a non-zero probability will inevitably happen in some universe. This means that somewhere there exists an infinite number of your exact copies, living out every conceivable and inconceivable version of your life. There are worlds where you made a different choice this morning, worlds where you were born in another country, and worlds where humanity followed a completely different path of development or never appeared at all. This is not just a philosophical concept, but a possible consequence of the laws of physics. Your uniqueness and the significance of your choices dissolve in this infinite ocean of probabilities, becoming a statistic, one of the countless stories told by the cosmos. One of the most profound and unsettling questions humanity has asked itself while looking at the stars is the Fermi paradox. The universe is vast and unimaginably old. In our galaxy alone, there are hundreds of billions of stars, and there are hundreds of billions of such galaxies in the observable universe. Statistically, life, including intelligent and technological life, should have arisen many times over billions of years. So, where is everybody? Why do we see no indisputable signs of alien civilizations' activities? No radio signals, no megastructures like Dyson spheres, no self-replicating probes. The cosmos is silent, and this great, deafening silence is more frightening than any scream, because it may mean that something terrible awaits us ahead. One of the darkest attempts to explain this paradox is the Great Filter hypothesis. It states that on the long evolutionary path from the simplest single-celled organisms to an interstellar civilization, there exists some extremely difficult barrier or filter that is nearly impossible to overcome. The horror of this hypothesis lies in the fact that we do not know where this filter is in our history. Either we have already miraculously passed it, and we are among the first to have succeeded, or it is still ahead of us. And this future filter could be anything. self-destruction in a nuclear war, irreversible ecological collapse, or the discovery of some fundamentally dangerous technology that is guaranteed to destroy its creator. Perhaps the very development of intelligence is an evolutionary dead end. Perhaps the issue is not filters, but simply the unimaginable scales of space and time, which render communication meaningless. The distances between stars are so vast that even if civilizations exist, they may be separated by thousands of light years. A radio signal sent from the star system nearest to us, Alpha Centauri, would take more than 4 years to arrive. And a signal from the other end of our galaxy, 100,000 years. Real-time communication is impossible. The universe may be full of intelligent life, but we are all doomed. To converse with ghosts, with civilizations that may die out long before their message reaches us, and whose reply we will never receive in our lifetime. We are all lonely islands in a boundless ocean of time, screaming into the void. Or perhaps alien civilizations are silent intentionally because they are afraid, and we should be doing the same. The dark forest hypothesis, based on the novel by Chinese science fiction author Liu Cixin, offers a chilling analogy. The universe is a dark forest, full of hiding hunters. Any civilization that announces its existence risks attracting the attention of more advanced and possibly paranoidly hostile civilizations. In this dark forest, the best way to survive is to remain silent, hide, and destroy anyone who reveals your location. By sending signals into space, we may be behaving like a naive child shouting in a jungle full of unseen predators. The silence of space is not emptiness, but concealed fear. The very act of observing and receiving information can be dangerous, turning knowledge into a weapon against ourselves. The concept of an informational hazard, or mimetic threat, suggests that there exist ideas, images, or fragments of information that could be harmful or destructive to the mind that perceives them. If we ever receive a complex and meaningful message from an alien civilization, we cannot be sure that it is safe to decode and understand. It could be a kind of Trojan horse for our consciousness, a cultural or logical virus capable of destroying our civilization from within. Some knowledge can be lethal, and the safest response to a call from the abyss is not to answer. Even if we find life, it might be completely alien to our understanding, to the point of being unrecognizable, and we might not even realize we have found it. We are searching for life as we know it, based on carbon as a structural element and water as a solvent. But other exotic forms of biochemistry are theoretically possible. For example, silicon-based life in a world of liquid methane, like on Titan, which would breathe hydrogen and exhale acetylene, or hypothetical life in the form of plasma self-organizing formations in the atmospheres of stars. We might encounter a form of life that we don't even recognize as living. So different would it be from anything we can imagine. We are searching for our own reflection, but we might find something absolutely different, something for which we don't even have a name. Time, which seems so fundamental and real to us, may also be an illusion, a product of our perception. Some advanced physical theories, especially in the field of quantum gravity, suggest that time is not a fundamental property of the universe. It arises as an emergent, i.e., derivative property from deeper, timeless laws, much like temperature arises from the motion of molecules. Our perception of the past, present, and future may be merely a feature of our consciousness. At a fundamental level, all moments of time may exist simultaneously in a so-called block universe. Your entire life, from birth to death, is already recorded in the fabric of space-time, and we are merely viewing it like a film, frame by frame. The ultimate fate of the universe itself also promises nothing joyful. It is predetermined and bleak. The most likely scenario today is heat death. Due to perpetual accelerated expansion, the universe will grow ever colder, darker, and emptier. Stars will go out one by one, turning into black dwarfs. Galaxies will fall apart. Even black holes will evaporate over unimaginably long trillions of years due to Hawking radiation. In the end, in the far, far future, only cooled elementary particles, photons, and neutrinos will remain, moving randomly and solitarily in the eternal darkness and cold, close to absolute zero. The universe will end not with a bang, but with a quiet, endless, slow fade into nothingness. In such a dying, empty universe, one of the most unsettling philosophical ideas arises: the concept of the Boltzmann brain. This is a hypothetical self-aware entity that could emerge from random quantum fluctuations in a state of thermodynamic equilibrium. Over an infinite amount of time, the probability of particles randomly assembling into a complex structure, like a human brain with a full set of false memories of a past, for example, of our universe, becomes non-zero. This leads to a paradoxical conclusion. It is statistically far more likely that you are such a lone, fluctuating brain dreaming up the universe than a real person in a real, ordered universe. Your existence may be just a random dream of the void. Even our reality, so solid and certain, may not be what it seems, but merely someone's program. The simulation hypothesis, which has become popular in philosophy and science, suggests that our universe and everything in it, including ourselves and our consciousness, is an extremely advanced computer simulation created by a more developed civilization. We cannot prove or disprove this from within the system. All the laws of physics that we discover with such difficulty may be just the rules of the program's code, the physics engine of the simulation. Our consciousness, our feelings, our memories, all of this could be part of the program, which its creators can pause, change, or turn off at any moment without warning. Our life may be just a game. Black holes may not only be the end of everything, but also a paradoxical beginning, gateways to other worlds. Some theories, such as Lee Smolin's black hole cosmology, suggest that a new universe could be born inside every black hole. Matter falling into a singularity might rebound and create its own Big Bang, possibly with slightly altered physical constants. This means that our universe itself might be inside a giant black hole, which in turn is part of an even larger parent universe. We might be just one link in an infinite chain of creation and destruction, like Matryoshka dolls nested within each other, where each doll is an entire cosmos, and our world is merely a descendant of another deceased world. In the vacuum of space, there is no sound in the sense we are accustomed to, but there are sounds of planets that we can hear by translating the language of space into our own. Spacecraft like Voyager or Cassini record not acoustic waves, but complex interactions of plasma, charged particles, and the magnetic fields of planets. If these electromagnetic oscillations are converted into the audible range accessible to the human ear, we hear the eerie, otherworldly songs and screams of Jupiter, Saturn, and even Earth. This is not music, but the voice of electromagnetic storms, particle streams, and auroras, a silent yet powerful chorus of the solar system, which we can only hear with the help of our technological ears. And this chorus sounds like something alien and frightening. The light from distant stars and galaxies takes millions and billions of years to reach us, turning the night sky into a time machine. This means that when we look at the night sky, we are looking into the past, at events that have long since passed. Many of the stars we see with the naked eye may have long since died out, exploded as supernovae, or turned into black holes. We see only their ghostly light, which has reached us eons after their death. The night sky is not a picture of the present moment, but a giant cosmic cemetery full of beautiful glowing tombstones whose light is still traveling towards us across the abyss, like a final goodbye sent thousands of years ago. There are objects that serve as the most precise clocks in the universe, and their ticking is the cry of a dead star. Their name is pulsars. These are rapidly rotating neutron stars that emit narrow, powerful beams of radio waves from their magnetic poles. If such a beam periodically crosses Earth as the star rotates, we detect it as a perfectly precise pulse, like the light from a distant and incredibly fast lighthouse. Some millisecond pulsars rotate at a furious speed, making hundreds of revolutions per second. These are cosmic clocks, ticking with a precision surpassing that of atomic clocks. But their ticking is the cry of a dying super-dense star hurtling through the void and reminding us of the most extreme states of matter. In space, there are structures of such a scale that they challenge our imagination and the very foundations of cosmology. The Hercules Corona Borealis Great Wall is the largest known structure in the universe, a gigantic filament or thread of galaxy clusters about 10 billion light-years long. Its existence borders on contradicting the cosmological principle, which states that on the largest scales, the universe should be homogeneous and isotropic. We are finding structures so vast that it takes light almost the entire age of the universe to cross them. This shows how little we truly understand about the large-scale structure of our world, about its hidden skeleton, which has turned out to be larger than we could have imagined. There is a phenomenon that permeates the entire history of galaxies, known as cosmic cannibalism, the slow and inevitable devouring of the weak by the strong. Large galaxies, like our Milky Way, grow and gain mass by absorbing smaller dwarf galaxies that come too close. Right now, our galaxy is in the process of tearing apart and consuming several of its satellites. For example, the Sagittarius dwarf galaxy. We can see stellar streams, long ribbons of stars stretched across the sky like ghostly scars. These are the remains of those galaxies that were torn apart by the Milky Way's tidal forces. Our stellar home is built on the bones of its smaller neighbors, and its history is written in stellar blood. And in the distant future, an even more grandiose collision awaits us, one that will change the face of our sky forever. In about 5 billion years, our Milky Way galaxy will collide and begin to merge with the neighboring giant spiral Andromeda galaxy, which is already hurtling toward us at a speed of 110 kilometers per second. This will not be a quick explosion, but a slow, majestic gravitational dance that will last for hundreds of millions of years, distorting both galaxies and ultimately creating a new, giant elliptical galaxy that astronomers have provisionally named Milkomeda. Stars are unlikely to collide directly due to the vast distances between them, but entire star systems will be thrown into new, chaotic orbits. The future of our home is a merger with another stellar giant in a final dance. Some of the strangest and brightest objects in the universe are quasars, beacons from the universe's youth. These are the active nuclei of very distant and, therefore, very young galaxies. At their center is a supermassive black hole that is currently actively consuming a huge amount of matter, gas, dust, and entire stars. This matter, falling into the black hole, forms a giant accretion disk around it. Due to friction and compression, this disk heats up to millions of degrees and begins to shine brighter than all the hundreds of billions of stars in its galaxy combined. Quasars are the brightest beacons in the universe, light from a turbulent era when galactic monsters were young, hungry, and insatiable. And their roar could be heard across the entire universe. In the center of our own galaxy, around the black hole Sagittarius A, stars move at incredible, dizzying speeds, subject to its monstrous gravity. The star S2, for example, completes a full orbit around the black hole in just 16 years, accelerating at the closest point of its orbit to 25 million kilometers per hour, which is about 3% of the speed of light. Observing these stars, their dance on the edge of the abyss, is direct and irrefutable proof of the black hole's existence and a unique opportunity to test the predictions of the general theory of relativity in the most extreme conditions we can possibly observe. It is a laboratory created by nature itself for studying the limits of physics. There is a theory that makes us look at our own origin in a new way, suggesting that we are all descendants of aliens. This is the panspermia hypothesis. It suggests that life, or its chemical precursors, did not necessarily originate on Earth. Microorganisms capable of surviving in extreme conditions can travel between planets and even between star systems, for example, by being enclosed within meteorites that protect them from radiation. This means that life on Earth could have a Martian or even an extrasolar origin. We ourselves may be the descendants of alien microbes delivered to our young planet billions of years ago. Our lineage may be rooted in the depths of space rather than in Earth's oceans. We have already talked about hot Jupiters, but some of them present a particularly sad spectacle, demonstrating the slow death of an entire world. These are gas giants orbiting so close to their stars that their atmospheres are heated to thousands of degrees and are constantly being blown away by the powerful stellar wind and radiation. These planets are literally losing their substance, which is carried away into space, leaving behind a giant tail of gas similar to a comet's. We can watch their slow and agonizing death as the star devours its own planet, layer by layer. Some of these planets may eventually evaporate completely, leaving behind only a bare, incandescent core, a silent monument to a dead world. There are planets that, in their composition, may resemble a jeweler's treasure chest more than our rocky world. The planet 55, Cancri E, orbiting a star in the constellation Cancer, is likely such a diamond world. It is twice the size of Earth and 8 times more massive, and it appears to be composed mainly of carbon rather than silicates, like Earth. The conditions in its interior, immense pressure and temperature, are such that a significant portion of this carbon must exist in the form of graphite and diamond. This is a world where entire continents and mountains could be made of the precious stone, but its surface is heated to 2400 degrees, and its atmosphere is dense and poisonous. A treasure that cannot be touched, an eternal and inaccessible jewel of the cosmos. Even the absolute emptiness of space is not truly empty. It seethes with invisible life. According to quantum field theory, the vacuum is filled with virtual particles that are constantly born in pairs, particle-antiparticle, from nothing and immediately annihilate, disappearing. This is a kind of quantum foam, boiling at the most fundamental level of reality, beyond our perception. The void lives its own, invisible and ephemeral life. This seemingly abstract concept has real consequences. It underlies Hawking radiation, which causes black holes to slowly lose mass and evaporate over unimaginably long periods of time, repaying their debt to the void. Our Earth, in its long history, has experienced several periods when it was almost completely covered in ice and snow, turning into an ice ball. These are the so-called snowball Earth eras. These were global glaciations when the average temperature on the planet dropped to -50 degrees Celsius, and glaciers reached the equator itself. Life during this harsh time, which lasted for millions of years, could only survive in small oases near geothermal vents, in subglacial lakes, or in a thin strip of meltwater at the equator. Our planet, now so green and blue, was several times on the brink of turning into an eternal, lifeless ice ball, from which it escaped only thanks to volcanic activity that accumulated greenhouse gases under the ice shell. In the cold and dark interstellar clouds where new stars are born, astronomers have discovered giant reservoirs of complex organic molecules, including alcohol. For example, the gas and dust cloud Sagittarius B2, located near the center of our galaxy, contains billions of liters of vinyl alcohol, and a cloud in the constellation Aquila contains enough ethyl alcohol to fill 400 trillion pints of beer. Of course, it is mixed with other poisonous chemicals, but the very fact that such huge reserves of organics exist suggests that the building blocks of life are widespread throughout the universe and can be incorporated into new planets. Space is drunk with the anticipation of life that it carries within itself. There is a class of hypothetical stellar objects so strange they seem like science fiction, true stellar chimeras. These are Thorne-Zhitkov objects. Theoretically, this is a hybrid star, a red giant or supergiant whose core is not a normal core, but an entire neutron star. Such an object could form from the merger of two stars in a close binary system, when a neutron star plunges into the interior of its giant companion. Outwardly, it would look like a normal red giant, but its chemical composition, enriched with the products of exotic nuclear reactions near the neutron core, would be completely unique. It is a true Frankenstein's monster of the astrophysics world, a star with a stellar corpse inside. Gravitational waves, predicted by Einstein 100 years ago and first directly detected in 2015, are nothing less than ripples in the very fabric of space-time. They are caused by the most catastrophic events in the universe, such as the merger of black holes or neutron stars. These waves propagate at the speed of light and pass through everything in their path, including the Earth and our bodies, momentarily stretching and compressing space by a minuscule, imperceptible amount. Right now, echoes of cosmic cataclysms that occurred millions and billions of years ago are passing through us, and we do not even notice them. We are constantly bathing in the gravitational echo of great past events, in the silent screams of dying giants. Some exoplanets, especially those orbiting dim red dwarfs, are tidally locked to their stars, doomed to eternal stillness. This means they always face their star with the same side, just as the moon does with the Earth. On such planets, one hemisphere is plunged into perpetual scorching day, while the other is in perpetual freezing night. The only potentially habitable zone, if life is possible at all, would be a narrow terminator strip, a zone of eternal sunset or sunrise between the two extremes. These would be worlds where the sun never moves across the sky, frozen at one point above the horizon, worlds of eternal twilight where life would have had to adapt to perpetual dusk. Antimatter is not science fiction, but a physical reality, a mirror image of our world. Every elementary particle, proton, electron, has a corresponding antiparticle with the same mass but an opposite electric charge, antiproton, positron. When a particle and an antiparticle collide, they annihilate, converting completely into pure energy in the form of gamma rays. It is believed that at the moment of the Big Bang, there were almost equal amounts of matter and antimatter in the universe. But for some still unknown reason, known as baryon asymmetry, a tiny excess of matter remained, about 1 particle per billion. This tiny remnant after the Great Annihilation is what everything we see today is made of: stars, planets, and ourselves. Our world is built on the ruins of a great war between matter and antimatter. On the surface of our sun, phenomena sometimes arise that are similar to terrestrial tsunamis, but on an unimaginable, truly hellish scale. These are the so-called solar tsunamis, or Morton waves, giant shock waves that propagate across the solar photosphere after powerful flares. These waves, composed of incandescent plasma, travel at speeds of up to 1,000 kilometers per second and can reach heights of 100,000 kilometers. They sweep across the surface of our star, compressing and heating everything in their path, like a giant ripple on the surface of a fiery ocean. These are literal waves of stellar matter, a visual manifestation of the colossal energy raging in the depths of our sun, and a reminder of its hidden power. Even the most stable-seeming planetary orbits in our solar system are not eternal or absolutely predictable. Due to complex and constant gravitational perturbations from other planets, the orbit of Earth and other bodies slowly and chaotically changes over time. Long-term calculations show that there is a tiny but non-zero probability that within the next few billion years, Mercury's orbit could become so unstable and elongated that it will either fall into the Sun, collide with Venus, or even be ejected toward Earth. The solar system is not a perfectly tuned clockwork mechanism, but a complex dynamic system with an element of chaos, where the future is not completely predetermined, and even planets can stray from their paths. In the center of some planetary nebulae, such as the Cat's Eye or Helix Nebula, we see incredibly complex concentric shells and structures of gas ejected by the dying star at the center. These shells are like the annual rings of a giant cosmic tree. Only each ring is not a year, but the result of a separate convulsion, an impulse with which the star shed matter, occurring perhaps every few thousand years. We see in these structures a frozen record of the star's death throes, stretched over millennia and frozen in space as a beautiful and sad monument to its life. It is a cosmic butterfly hatched from the cocoon of a dying star, and its wings tell the story of its death. Some of the most powerful cosmic rays reaching Earth, the so-called ultra-high energy particles or oh my god particles, possess an energy that seems impossible. The energy of a single such subatomic particle, usually a proton, is comparable to the kinetic energy of a baseball traveling at 100 kilometers per hour, and is tens of millions of times greater than what can be achieved in the most powerful accelerators on Earth. We still do not know for sure what cosmic accelerators, perhaps active galactic nuclei or gamma-ray bursts, are capable of generating such energetic monsters and sending them on a journey across the entire universe. These are messengers from the most violent corners of the cosmos, and we still do not understand their language. Our moon, Earth's faithful and silent companion, a poetic symbol of eternity, is slowly but inexorably moving away from us. Due to the tidal interaction that causes the ebb and flow of the oceans, the moon takes some of Earth's rotational energy and uses it to expand its orbit. The speed of this recession is about 3.8 centimeters per year, roughly the same speed at which our fingernails grow. This means that in the distant past, the moon was much closer to Earth, appeared much larger in the sky, and the tides were gigantic. And in the distant future, it will be so far away that its visible disk will become too small to completely cover the sun, and total solar eclipses will become impossible. Our satellite is slowly leaving us, taking a piece of our history with it. In the map of the cosmic microwave background, the oldest light in the universe, a strange and unexplained anomaly was discovered, unofficially named the Axis of Evil. This is an unexpected alignment of some large-scale structures, hot and cold spots, with the ecliptic plane of the solar system, that is, the plane in which the planets orbit the sun. This is an extremely unlikely coincidence that hints either at some completely unknown physics linking the entire universe to our tiny system, or at a systematic error in the data. This anomaly makes cosmologists feel uneasy because it subtly violates the Copernican principle, which states that our place in the universe is in no way special. Perhaps we are special in some way after all. Our neighbor, Mars, was not always the cold, dry, red desert we know today. A great deal of data suggests that billions of years ago, it was a much warmer and wetter world with a dense atmosphere and, possibly, rivers, lakes, and even oceans of liquid water. But Mars, being smaller than Earth, cooled faster, its core solidified, and it lost its global magnetic field. Deprived of this protective shield, the planet was left defenseless against the solar wind, which over millions of years blew away most of its atmosphere and water into space. We see dried-up riverbeds and deltas on Mars, ghosts of a bygone, more hospitable era. This is a stark example of how quickly and easily a world can die, turning into a rusty monument to itself. In the cold of interstellar space, within gas and dust clouds, float not only simple molecules but also complex organic compounds, including polycyclic aromatic hydrocarbons, PAHs. Ironically, these are the same compounds that are formed during the incomplete combustion of organic matter on Earth, for example in car exhaust or cigarette smoke, and are considered carcinogens. Space is literally saturated with this complex soot from burnt-out stars and other astrochemical processes. These molecules floating in space can serve as the raw material, the building blocks for the origin of life, when they land on young, forming planets. Space is full of the same soot as our cities, only on an unimaginable scale. Around some white dwarfs, the dense and hot dead remnants of stars, astronomers have discovered dust and debris disks rich in heavy elements. This is irrefutable evidence that after the star's death, its planetary system was destroyed. When the star turned into a red giant and then shed its outer layers, the orbits of the surviving planets and asteroids became destabilized. Some of them were torn apart by the tidal forces of the dead star and now orbit it in the form of debris. We see true graveyards of planetary systems orbiting stellar corpses like Saturn's rings, only composed of worlds similar to our own, ground into dust. There is a subtle but important non-gravitational effect that affects the motion of small celestial bodies, slowly changing their fate. This is the Yarkovsky effect. The effect is that small rotating asteroids can change their orbit under the influence of sunlight. The uneven heating of an asteroid's surface and the subsequent asymmetrical radiation of heat in the infrared range create a tiny but constant reactive thrust. Over millions of years, this minuscule force, comparable to the weight of a snowflake, is capable of significantly altering an asteroid's trajectory, turning a completely safe object into a potential threat to Earth, or vice versa. Light itself, silently and invisibly, can push rocks in our direction like an invisible hand. Some cosmological models suggest that the universe may be cyclical, undergoing an endless series of births and deaths, like the mythical phoenix bird. After the heat death, or perhaps the Big Rip, some process may occur that will trigger a new Big Bang and the birth of a new universe. This could be a quantum fluctuation in empty space, or the collapse of the entire universe into a single point within the so-called Big Bounce model. In this fascinating worldview, our universe is just one in an infinite series of creation cycles. Our entire world, all its history, is but a single breath, a single heartbeat in the eternal cycle of cosmic existence, and our death is merely a prelude to a new birth. Some of the oldest stars in our galaxy, inhabiting ancient globular clusters, are true living witnesses to the creation of the world. These stars, belonging to the so-called Population 2, have an age comparable to the age of the universe itself, more than 13 billion years. They consist almost entirely of hydrogen and helium, the primordial elements synthesized in the first minutes after the Big Bang. They contain almost no heavy elements, metals, which are formed in the cores of stars and scattered by their explosions. They are living fossils, witnesses to the very dawn of time, who have seen the birth and death of most of the stars in our galaxy and carry in their light the memory of a young, pure universe that had not yet known death. Mysterious signals known as fast radio bursts, FRBs, short cries from beyond our galaxy, reach us from the depths of space. These are extremely powerful but very short pulses of radio emission, lasting a few milliseconds, coming from distant galaxies. Their exact source is still unknown, but the energy released in one such burst in a fraction of a second is comparable to the energy our sun radiates over several days. Hypotheses about their origin range from the flares of young magnetars to the collisions of neutron stars, and even, on the fringes of science, to signals of alien technologies. We hear these mysterious cries from all corners of the universe and are not yet able to understand their nature, feeling like listeners in a dark room. Even if we one day find a planet in every way similar to Earth, it may not be the best place for life, but merely a pale copy. Astronomers have introduced the concept of a superhabitable planet, a hypothetical world that may have conditions for the emergence and sustenance of life even better than our own. For example, it could be a planet slightly larger and more massive than Earth, with stronger gravity that retains a denser atmosphere. It might have a shallower ocean, fragmented into archipelagos for greater biodiversity, and a longer-lived and more stable host star than our Sun. This makes one wonder if our Earth is not the pinnacle of creation, but simply a good enough planet, one of many, and that somewhere there are worlds that are true paradises. Cosmic dust, which seems to us like mere dirt, interfering with astronomical observations, actually plays a key role in the chemistry of the universe. These microscopic particles, consisting of silicate or carbon cores coated with water ice, are catalysts for the formation of complex molecules. On their cold surfaces, individual atoms floating in interstellar gas can meet, stick, and combine with each other, forming water, methane, ammonia, and simple organic matter. Cosmic dust is not debris, but tiny chemical factories where, in the cold and darkness, the very building blocks from which life can later be constructed are created. The very dirt of space carries the seeds of future creation. Our solar system is not flying through an absolute vacuum. We are sailing in a cloud of stardust. Right now, we are moving through a region of slightly denser interstellar gas and dust known as the local interstellar cloud. We entered this cloud several tens of thousands of years ago and are projected to exit it in 10,000 to 20,000 years. This cloud poses no direct danger to us, but it reminds us that interstellar space is not a void, but a complex environment with its own structure, currents, clouds, and weather. We are travelers passing through different climatic zones of our galaxy, and our journey is far from over. Black holes can not only silently consume matter, but also sing in the lowest note in the universe. Astronomers observing the giant Perseus galaxy cluster discovered that the supermassive black hole at its center, by consuming gas, creates ripples in the surrounding hot plasma, concentric pressure waves. These are, in essence, sound waves. Scientists were able to determine their pitch. It corresponds to the note of B-flat, but 57 octaves below middle C on a piano. This is the lowest note ever detected in the universe, with an oscillation period of 10 million years. It is a literal, deep, inaudible hum produced by a cosmic monster during its meal, the eternal music of the abyss. Light, which seems so immaterial to us, actually exerts pressure on objects it interacts with. It can push and move them. Although it is negligible under terrestrial conditions, in space, solar pressure can influence the orbits of satellites and is the basis for the futuristic concept of solar sails, spacecraft propelled by light pressure. Stars literally blow on everything around them with their light. This invisible but constant wind of photons can move objects in space, slowly but inexorably, over millions of years, like a ghostly breath changing the trajectories of asteroids and comets. Due to the finite speed of light, we can never see the universe as it is now, at this very moment. We always see only its past. And because of the accelerated expansion of the universe, there exists a cosmic horizon, an imaginary boundary beyond which objects are receding from us faster than the speed of light, and their light can never reach us. This means that there is a vast, possibly infinite part of the universe that we not only cannot see, but can never in principle see. Our knowledge of the world is fundamentally and forever limited by this horizon of visibility, beyond which lies eternal unknown. We are locked in our small bubble of the visible cosmos. The very concept of a single now for the entire universe is an illusion born of our intuition. According to the special theory of relativity, there is no universal present moment. Two observers moving at different speeds relative to each other will have different ideas about which events in distant galaxies are happening simultaneously. Your now does not coincide with the now of a hypothetical observer in the Andromeda galaxy. Time, like space, is relative, and the concept of a present moment is only meaningful for a specific observer at a specific point. The universe does not live in a single present. It is a mosaic of countless nows that will never converge. Even if humanity avoids all cosmic threats and self-destruction, life on Earth itself, in its current form, is doomed to a heat death. As our sun ages, it slowly but steadily becomes brighter, even long before turning into a red giant. Because of this, the temperature on Earth will gradually rise. According to calculations, in about 1 billion years, the average surface temperature will reach a level where the oceans will begin to boil away intensely, triggering a runaway greenhouse effect. Life as we know it will become impossible. The cradle of humanity has its expiration date, and it is slowly running out, like sand in an hourglass, counting down the time until Earth transforms into a new, lifeless Venus. There are galaxies composed almost entirely of invisible dark matter, true ghosts in the world of stars. These so-called ultra-diffuse galaxies are comparable in size to the Milky Way, but contain hundreds and thousands of times fewer stars. They are so sparse that they appear almost transparent, with more distant objects visible through them. These are true phantom galaxies, consisting mainly of invisible substance, where stars are merely rare, solitary sparks lost in a vast, dark halo. They are living proof that dark matter is not just a theory, but the primary building material for galaxies, and that the universe is full of invisible structures we are only just beginning to notice. The very fabric of reality, space, and time might not be smooth and continuous, but discrete, composed of indivisible quanta. Some theories of quantum gravity, such as loop quantum gravity, propose that there is a minimum possible length, the Planck length, and a minimum possible interval of time, the Planck time. At this most fundamental level, our reality may not be smooth and analog, but granular, like a digital image on a screen. We live in a world that might have its own pixelation, just on an unimaginably small scale, and all our movement is merely a transition from one quantum of space to another. And finally, the quietest and most profound of all horrors is not an external threat, but the realization of our complete, absolute solitude. Not in the sense of the absence of other intelligent beings, but in the sense of the incomprehensibility of the scales and our insignificance to them. Every star is a potential sun. Every dim point of light in a telescope's image is a galaxy with billions of suns. And between them is emptiness, cold, and silence, measured by eternity. We are but a fleeting, complex thought in the infinite mind of the cosmos, a tiny spark of consciousness on a dust mote hurtling through the abyss. And this abyss gazes back at us not with malice or love, but with complete, absolute, divine indifference, and in this indifference lies true freedom and true horror. We have peered into the abyss, not so that it might consume us, but to see the light of our own small world more clearly. These eerie truths of the cosmos do not diminish the value of our lives, but on the contrary emphasize their fragility and uniqueness. Our warm, living moment is a miracle against the backdrop of the cold, silent grandeur of eternity. And in this realization, one can find not fear, but a deep, quiet peace. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and let the quiet abysses of space lull your thoughts. Good night.